Hello, so today we are talking about dividing polynomials by long division. So this would be similar to probably what you dealt with in elementary school and middle school, dividing numbers, but now we're dividing algebraic expressions. In the textbook, you can follow along section 4.3. Again, this is the Glencoe Algebra 2 2018 edition textbook on page 242. So again, if we're just dividing by a monomial, single term, all we have to do is just divide the monomial into each piece of the polynomial. So pretty much we're just going to separate out into 3, 4, 5, however polynomial parts there are, into separate fractions. So for example, if we see it like this, we have 6x to the 4th y cubed plus 12x cubed y squared minus 18x squared y divided by 3xy. We just simply want to separate them out. 6x to the 4th y cubed over 3xy, and then plus 12x cubed y squared over 3xy, and minus 18x squared y over 3xy. Now we just try and simplify each one of these fractions. So for the first fraction, 6 divided by 3 is 2. X to the 4th over x is x cubed. Y cubed over y is y squared. And then we continue that for the rest of them. 12 divided by 3 is 4. X cubed over x is x squared. Y squared over y is just y. And then minus 18 over 3 is 6. X squared over x is x. And the y's cancel, leaving this as our expression. So that's all we're working with when we're dividing by a monomial term. Just simply separate them out into separate fractions and then reduce each of the fractions as you're working through the problem. Fairly straightforward. Now, something to point out. If you're multiplying a polynomial with a monomial, or any other term really, and the second term has a negative 1 exponent, this is the same process as division. The textbook writes it like this every now and then, so that's why I want to make sure I include a couple examples like this. So again, we're not multiplying these together. Since the second term has a negative 1 exponent, it means they're dividing. So we'll separate out again 20c to the 4th d squared f over 4c df minus 16c df squared over 4c df and plus 4c df divided by 4c df. As we go through, 20 divided by 4 is 5. C to the 4th over c is c cubed. D squared over d is d. And the f's cancel. Minus 16 over 4 is 4. C's cancel, d's cancel. F squared over f is just simply f. And then for the last term, we notice everything cancels, so we need to make sure we put a 1 there. Because remember, if we have the same number up top in the denominator for a fraction, then that just simply cancels down to a 1. Alright, so the big thing really is, again, we're separating out 3 separate fractions, recognizing that the negative 1 exponent for the second piece of this process doesn't mean to multiply the two of them, it means to divide them. Now, if we're dividing a polynomial by another polynomial, we're going to set up a long division problem similar to what we did in grade school. Where, for example, if we wanted to do 6 into 52, 6 goes into 52 8 times. 8 times 6 is 48. Subtracting out 4, and that's our remainder. So one way we could write this would be 8 4 over 6, which obviously then that 4 over 6 reduces. We're going to be doing the same general idea with these polynomials, and I'll show you what I mean by that. So if we're doing x squared plus 3x minus 40 divided by x minus 5, well, whatever we're dividing by is on the outside of our long division, and the first part's on the inside. Now the way this works is we'll divide the first term and the first term. X squared divided by x is just simply x. And then whatever we have up top, we now multiply with on the outside. So x times x is x squared. X times negative 5 is negative 5x. We now subtract the two terms. X squared minus x squared is 0, cancels. That should happen. We need to be careful with subtractions. If we have negatives, you got to remember that 3 minus a negative 5 becomes 3 plus 5. So that's why this is 8x. And then we carry down the next term and repeat the process. We divide the first terms by each other. So 8x divided by x is 8. And then whatever's up top, we now multiply. 8 times x is 8x. 8 times negative 5 is negative 40. Again, subtracting. 8 minus 8 is 0. The x's cancel. That was supposed to happen. Negative 40 minus a negative 40 becomes negative 40 plus 40, which is 0. So this tells us the remainder is 0, which means as x minus 5 goes into it perfectly. So the answer would just be x plus 8. So that's the general process behind long division. The things that will change obviously is the coefficients in front of these variables and how long or how big they are, stuff like that. So we take a look at this one. Again, it means we're dividing. So we have y minus 2 dividing into y to the 5th. And you notice we're missing a y to the 4th and a y cubed term. So it would be a good idea to put a 0 y to the 4th and a 0 y cubed term in between the y to the 5th and negative 3y squared. So we're missing a 0y term, putting it as plus 0y minus 19 in there. You can technically do the problem correctly without something like that, but it allows you to be more careful when you're doing your multiplication and subtraction process and what's carrying down next for the setup, so that's why it's important to set them up like this. Okay, so always put in 0 placeholders for missing terms. So we begin, first term divided by the first term. Y to the 5th divided by y is y to the 4th. We now multiply, so y to the 4th times y is y to the 5th, and then minus 2y to the 4th. Again, we're subtracting. Y to the 5th is canceled, and this is where we're having the 0 y to the 4th is important, because it's 0 minus a negative 2, 0 plus 2, so it's 2y to the 4th. And then again, we'll carry down the next term. Well, now we do the first term division again. 2y to the 4th divided by y is a 2y cubed. So when we multiply that to the outside, we'll get 2y to the 4th minus 4y cubed. Again, we subtract. Y 4ths cancel. 0 minus a negative 4 is 0 plus 4, so it becomes 4y cubed. Now we carry down the negative 3y squared. And the reason why I'm starting to write progressively smaller is because I'm recognizing I'm going to start running out of room here. So I'm trying to fit this all on one page without me having to erase anything. Anyway, so now we divide the first terms again. 4y cubed divided by y is a 4y squared. So then we multiply. We'll get 4y cubed minus 8y squared. When we subtract, the 4y cubes cancel. Negative 3 minus a negative 8 becomes negative 3 plus 8, so it's a positive 5y squared. Then we carry down the 0y. Same thing. First terms, 5y squared divided by y is 5y. We multiply that, so we get 5y squared minus 10y. We subtract. The 5y squareds cancel. 0 minus a negative 10 becomes 0 plus 10, so it's positive 10y. And then we bring down negative 19. So first terms again. 10y divided by y is just 10. So then we get 10y minus 20. When we subtract, the y's cancel. Negative 19 minus a negative 20 becomes negative 19 plus 20, so it's a 1. Now there are no more terms to carry down, and this last number right here, we cannot divide y by it and come up with anything besides a fraction. So that tells us that's our remainder, so we'll write it as, so our final answer is y to the 4th plus 2y cubed plus 4y squared plus 5y plus 10 plus, because it's a positive remainder, 1 over what we divide into, we divide by y minus 2. Alright, so that's the process behind how the long division is working. Again, step by step, we're just dividing the first term by the outside first term. Whatever that gives us, that goes up top, and then we multiply that to the outside, and subtract that, and then repeat the process until we get down to either a number, no variables, or, depending upon the problem, something, even if it's a variable left over, it has a lower exponent than what's on the outside. Like if this had been y squared minus 2, then we would have stopped at the 10y minus 19 part, because then 10y can't go into, I'm sorry, the other way around, y squared can't go into 10y. Alright, now if we have a coefficient in front of it, it's still the same idea. So we still putting the 2x plus 1 on the outside, still having our 8x to the fourth, and then 0x cubed because we're missing that term, minus 4x squared plus x plus 4. So our first terms, 8x to the fourth divided by 2x is 4x cubed. Multiply, 8x to the fourth plus 4x cubed. When we subtract, 8's cancel, 0 minus 4 is negative 4. We carry down the negative 4x squared. Negative 4x cubed divided by positive 2x is a negative 2x squared. You multiply that across. Get negative 4x cubed minus 2x squared. When we subtract that, the x cubes cancel. Negative 4 minus negative 2, negative 4 plus 2. We get negative 2x squared. Carry down the x. Negative 2x squared divided by 2x is a negative x. So then we get our negative 2x squared minus x. Subtracting. Negative 2x squareds cancel. X minus negative x becomes x plus x, so that's 2x plus 4. 2x divided by 2x is 1, so we'll put a 1 there. Multiply to get 2x plus 1. Subtract. 2x's cancel. 3. And again, we're down to a number, so therefore we know we're done. So the final answer would be 4x cubed minus 2x squared minus x plus 1. Positive remainder, so plus 3 over 2x plus 1. Alright, so we have this other long division problem we're going to set up. This time now we're dividing by a quadratic. Despite the term at the end being a quadratic, it's still the same general process. We're going to set up x squared plus 2x minus 1 on the outside. And we're going to put the x to the fourth plus 3x cubed minus x squared minus 5x plus 2 on the inside. So again, we divide the first terms together. X to the fourth divided by x squared is x squared. And then we multiply from the top to the outside and get x to the fourth plus 2x cubed minus x squared. So when we subtract these terms, the x fourths cancel. 3 minus 2 is x cubed. Negative x squared minus negative x squared becomes negative x squared plus x squared, which cancels. So right is 0x squared, just so we have our proper placeholder. We'll carry down the negative 5x. So now x cubed divided by x squared is x. So now we multiply across, we get x cubed plus 2x squared minus x. So when we subtract this expression, x cubes cancel. 0 minus 2 is negative 2x squared. Negative 5 minus negative x becomes negative 5 plus x, which is negative 4x. Then we carry down the positive 2. Again, first terms, negative 2x squared divided by x squared is negative 2. So it becomes negative 2x squared minus 4x plus 2. When we subtract these terms, we notice we're subtracting the exact same expression, so the remainder is 0. So our answer is just x squared plus x minus 2. Okay, and that's how long division works. Again, in the next video, we'll talk about a trick to use for when we divide by binomials. So if we were dividing by a quadratic, we have to use the long division method. But if we have a binomial, similar to examples 3 through 4, we can use the trick we're going to talk about next time. Alright, so thank you for watching, and I'll see you next time.